Again, welcome to DSRT 734 class. These lectures cover discrete probability distributions. Our main objective is to explain the difference between discrete random variables and continuous random variables. We're also going to construct a discrete probability distribution and its graph. Also, we are going to determine if a distribution is a probability distribution. We're also going to learn how to find the mean, variance, standard deviation of a discrete probability distribution, and also how to find the expected value of a discrete probability distribution. Now, the expected value of a discrete probability distribution is the same as the mean value. So we start with random variables. Here we say the random variable represents a numerical value associated with each outcome of a probability distribution, and is normally denoted by the letter X. For example, the number of sales calls a salesperson makes in one day. This would be an example of a random variable. And we have two types of random variable, which is the discrete and also continuous random variable. Now, the discrete random variable is based on counting. So the example here, the number of sales calls a salesperson makes in one day, this would be a discrete random variable because it's based on counting. Hours spent on sales calls in one day, this will be continuous random variable. Now, continuous random variable is based on measurement. So here we see a discrete random variable has a finite or countable number of possible outcomes that can be listed. So again, discrete random variable is based on counting. So example given here, the number of sales calls a salesperson makes in one day. And then we have continuous random variable. Continuous random variable has an uncountable number of possible outcomes, which can be represented by an interval on the number line. So which means a continuous random variable can be a decimal number also. Again, it's based on measurement. So example, your hours spent on sales calls in one day. Decided whether a random variable X is discrete or continuous. Number one, the number of stocks in the Dow Jones Industrial Average that have share price increases on a given day. Now, the key word is the number of stocks. This is based on counting. We are going to count the number of stocks in the Dow Jones Industrial Average that have a share price increases on a given day. So the solution again will be discrete random variable. It's based on the number of stocks counting. Now, second is the volume of water in a 32-ounce container. This will be based on measurement. So this will be, again, continuous random variable. Continuous random variable, the amount of water can be any volume between 0 ounces to 32 ounces based on measurement. We have discrete probability distribution. Now, discrete probability distribution will be all the lists or the list in each possible value the random variable can assume together with its probability. So example of a discrete probability distribution will be if I toss a coin, the possible number of outcome is head and tail. And it will be half and half since they are factor. The total probabilities of all the possible outcome is 1. So if I toss a coin, the head will be half probability, the tail also will be half. Now, if I roll a die have 6 sides. So it will be 1, 6, 1, 6, 1, 6, 6 times. 1 will be 1, 6 probability, 2 will be 1, 6 probability, 3 will be 1, 6 probability to 6. So let's see in words here. They say here the probability of each value of a discrete random variable is between 0 and 1, inclusive, including the 0 and also the 1. And the total should be 1. So the sum of all the probabilities is 1. Again, Discrete probability distribution is the least each possible value the random variable can assume together with its probability. So again, tossing a coin, it will be half and half, head half, tail half. Those are the two probabilities between 0 to 1 value. The sum of two halves will be 1. Now, let S be a discrete random variable with a possible outcome of S1, S2, up to Sn. First, we are going to make a frequency distribution for the possible outcome. Then we find the sum of the frequencies. Then we find the probability of each possible outcome by dividing its frequency by the sum of the frequency. And that will give us the probability of each outcome. Then we check that each probability value should be between 0 and 1, and also the sum should be 1. So this example given, an industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Now, individuals were given a score from 1 to 5, where 1 was extremely passive and 5 was extremely aggressive. Now, a score of 3 indicating neither trait. Construct a probability distribution for the random variable x, then graph the distribution using histogram. Now, we know first column is the score. So the score of possible outcome is between 1 to 5. The frequency here is based on out of the 150 employee, 24 have 1 score, 33 have 2 scores. So those are the outcome. Up to the last one, 5 score, we have 21. So to come up with the probability distribution, we are going to find the probability of each score. Now we know probability of 1 will be 24 over 150. Again, 150 is the total employee. 24 is the employees that have the score of 1. Probability of 2, we have a total of 33 out of the 150. So it's like we are finding the relative frequency for the scores from 1 to 5. For example, probability of having 5 score, we have 21 employees that have 5, we divide by 150. Now, if we had all the probabilities value from P at 1 to P at 5, we should get 1. So 0.16 plus 0.22 plus 0.28 plus 0.20 plus 0.14 give us 1. Now, that's where we do our calculations. We had all the values, we get 1. And we can see that the probability of each outcome, it should be between 0 and 1 inclusive. Then we can construct the histogram. Histogram, as we said earlier, the categories will always be the horizontal. Then the frequency will be vertical line. So we have 5 different scores. So we have 5 bars. And for score 1, the probability value there was 0.16. So we are using the probability 0.16, 0.22 to construct all the 5 scores. Now, yes, we said because the width of each bar is 1, the area of each bar is equal to the probability of a particular outcome. Now, let's go to the mean. How do we find the mean of a discrete probability distribution? We know looking for a mean of a univariable data, for example, the mean of a final exam score. We had all the scores and we divide by the number of scores we have. Here, if we are looking for the mean of a discrete probability distribution, to be the sum of all the x values, which is the random variable, times the probability of that random variable. So for example, the score was 1, the probability of it was, let's say 0.16. The score was 2, the probability of it was 0.14. So we are going to multiply each value, the score times its probability plus the second score times its probability. So here we say each value of x is multiplied by its corresponding probability. Then the product are added together. So this is our example again. Remember our first score, the probability was 0.16, 2 score 0.22, 3 score 0.28, 4 score 0.20, 5 score 0.14. So if I'm going to look for the finding the mean or the expected value here, we are going to multiply 1 with 0.16 plus 2 times 0.22 plus 3 times 0.28 plus 4 times 0.20 plus 5 times 0.14. So that's what we have here. We multiply 1 by 0.16, we get 0.16. 2 times 0.22 give us 0.44. 3 times 0.28 give us 0.84. 4 times 0.20 give us 0.80. Then 5 times 0.14 give us 0.70. We had all the products, we get 2.94. So the mean of the discrete probability distribution, the sum of x times the probability of x is equal to 2.94. Next, we can also find the variance and also the standard deviation of discrete probability distribution. Now, to find the variance, we find the difference between each value and the mean. Then we square it, we multiply the probability by x, that is the S category value. Then to find the standard deviation to be square root of the variance. So what we mean to say, for example, here we find the mean to be 2.94. If I want to find the variance of this, I will find the difference of 2.94 and the x value, so 1 minus 2.94 times its probability, which is 0.16, plus 2 minus 2.94 all squared times its probability, 3 minus 2.94 all squared times its probability. So that's the formula here. Each value s minus the mean all squared times its probability, the probability of the x value. Then when we get the variance, to find the standard deviation, we just find the square root of the variance. So let's continue with the same example here. We already find the mean to be 2.94. So to find the variance, we are subtracting the difference of each s value and the mean of 2.94. So we get negative 1.94, negative 0.94, 0.06, 1.06, 2.06. That's the difference of each value and the mean. Then we need to square it. So we square the value, negative 1.94 square will give me 3.764. Negative 0.94 square will give me 0.884. 0.06 square will give me 0.004. Then 1.06 square will give me 1.124. 2.06 square will give me 4.244. Then we sum everything up. So we had everything, we get 1.616. So that's the formula again. The difference of each s value and the mean all square times the probability of x, the sum of all the categories. So if we know the variance, to find the standard deviation will be the square root of the variance, which will give us 1.3. Again, from the formula here, we have the x value is our category score from 1 to 5. We find the mean to be 2.94. So subtract each s value from the mean and square. And that's what we have in the third column for each value, 5 values. I would say 5 categories of scores. Then after that, we multiply by its probability. So the first one, 3.764, we multiply by its probability, which is 0.16. That's what we have here. Then the second score, 0.884, times its probability is 0.22. Then after we finish, we have the summation. We sum everything, all the 5, and that gives us 1.616. So that will be the variance. To find the standard deviation, it will be square root of 1.616, which approximately will give us 1.3. Now, next is the expected value. We say the expected value of a discrete random variable, which is equal to the mean of the random variable. So that's what we said earlier. To find the mean is the same as expected value. So here we say y at x, which is the mean, is the sum of x times the probability of x. So again, multiply each s category by its probability. Then we sum all of them. So the same step as finding the mean. So example here, at a raffle, we have 1,500 tickets that were sold at $2 each for 4 prices of 500, 250, 150, and 75. So we buy the lottery ticket for $2. We have total of 1,500 tickets to sell. The prices we can get is 500, 250, 150, 75. Now here we say you buy one ticket. What is the expected value of your gain? So remember, expected value, the same concept as looking for the mean. So we have our category. First of all, we find the mean, which is given to us to be 2. That's sold at $2 each for the prices of this. So we subtract the 2 from each prices, and we get 498, 248, 148, 73. Then from there, if you do not win a prize, your gain will be what? 0 minus 2. So it will be minus 2. If I win a price of 500, my gain will be 498, 250, 248, because I bought $2 ticket. Now, if I don't win nothing, which means 0, it will be 0 minus 2, which means my answer will be negative $2. I lose $2. Our goal is to find the probability distribution for the possible gains. So we can see 498, the possible total is 1,500 tickets. So 498 gain is only one price, so it's 1 over that amount. 248, 1 over the same total, 148, 173 also. So because the first 4 prices, we're going to get only one winner at a time. Now the remaining will be loss. So total ticket is 1,500, subtract 4 from it, we get 1,496 divided by 1,500. Now, this will be our probability distribution. The probability of winning $498, gaining $498 because you win 500, but you buy the ticket $2. It will be 1 over 1,500. Since we're going to get only one winner from each category, it will be 1 over 1,500. Then if 4 win, the remaining 1,496 cannot win. So here we say the expected value. Again, we have 498 times 1 divided by 1,500 plus 248 times 1 divided by 1,500 plus 148 times 1 divided by 1,500 plus 73 times 1 over 500 plus minus 2 times 1,496 by 1,500. Sorry, I say 500 is 1,500 each. So when we do our production and product of everything, our final answer will be negative 1.35. So this means average or expectedly, you will lose average of $1.35 for each ticket you buy. So that will be the conclusion of these lectures. Again, these lectures will focus on the concept of, again, discrete and also continuous random variables. And then we learn how to find the mean, also the variance, the standard deviation, expected value of discrete probability distribution. Thank you for your time.